All right, so today what we're doing is we're looking at adding and subtracting polynomials. Well, in order for you to do this, first we got to actually talk what polynomials are. So we're going to get into some definitions. There's a lot of definitions in this, so make sure you get those because as I go through, you're going to need to be able to identify these based on their definitions. So make sure you get them. All right, a polynomial is a monomial or the sum of monomials, each called a term of the polynomial. Some polynomials have special names, as binomial is the sum of two monomials, and a trinomial is the sum of three monomials. All right. Monomials are basically a term with a variable, and that's what you're looking at. So that's one with this x here, right? It's a term that stands by itself. A binomial is two terms with different, not different variables, but with different exponents on top of them, right? So we have x to the second here plus 7. If this had an x out to it, it would still be a binomial, okay? So there's just two terms there, and you can't combine them. That's what you're looking at, okay? A trinomial is three terms, all with different exponents is what you're looking at. So x to the third minus 10x plus 1. See how you can't combine them because they don't like terms. This sets you up to have a trinomial, and that's really all you're looking at here. But you've got to be able to identify these, right? When you see them, you're going to need to be able to say, hey, that's a monomial. That's a binomial. There's two of them. That's a trinomial. And then a polynomial is really just talking about many, right? Many different terms. That's what you're talking about. So the degree of a monomial is the sum of the exponents of all its variables. A non-zero constant term has a degree of 0, and a 0 has no degree. All right. What this is saying is the degree of monomial. So we have a monomial here. Well, we look at this exponent, and all the exponents we look at this variable. Let me say it right. You look at the variable, and all the variables inside there, and you count up their exponents, and that's the degree of that monomial. Here we have one variable, and we have a 1 up here. If it's not there, it's an imaginary 1. So the degree of this monomial is 1. That's what you're looking at. So if this had a z next to it, so 5xz, the degree would be 2 because you would take that exponent of the x and the exponent of the z, you would add those two together. That gives you your degree. That's what that's talking about when it says the degree of a monomial, okay? And that's all it is, right? So the degree of a polynomial is the greatest degree of any term in the polynomial. So you're looking for the term with the highest degree, and that's the degree of the polynomial. So like up here, you have x to the third minus 10x plus 1. Well, this one has the highest degree because it has a degree or an exponent of 3. So the degree of this trinomial is 3. And that's what it's talking about. You can find the degree of polynomial by finding the degree of each term. Polynomials are named based on their degree. So that's what that is. All right? And then you come down here, and this is where I'm sitting here saying you're going to have to be able to identify these things. This is what we're talking about here. Determine whether each expression is a polynomial. If it is a polynomial, find the degree and determine whether it's a monomial, binomial, or trinomial. So here, we have this right here, 4y minus 5xz. Well, two terms, binomial. And then the degree of this is 2, because the x is raised to the first, the z is raised to the first. That's 2. You combine them. So, yes, it is a polynomial. The degree is 2, and it's a binomial. That's all it's talking about. All right? Negative 6.5, yes, it's a polynomial, even though it doesn't have a variable there. Okay? And it's a monomial. So what this is considered is, if you had a variable here, it would be considered raised to the zero degree, or 0 exponent, x to 0. Because any number raised to the 0 power, there it is, power. Any number raised to the 0 power is 1. Well, negative 6.5 times 1 is still negative 6.5. That's what they're talking about here. So this is a monomial, and the degree is 0. Now this one, 7a negative third plus 9b, well, remember your exponent rules. If you have a negative exponent, it's just on the wrong side of the fraction line. So what this ends up being is this is moved down to division. Well, we don't have division inside of our polynomials unless it's, say, just the number 1/3, something like that. We don't want our variables on the bottom of a fraction line inside of these polynomials. So no, this is not a polynomial because of the way that sets up. All right, so when you see that, that's the way they're going to show you a non-polynomial is right there. Be aware of that. Okay, so no, this is not a polynomial. Right here, yes, it's a polynomial. Its third degree is here because 6x to the third. Now notice, look right here, 4x plus x. You can combine those two things, okay? You can combine those like terms, but it's still it's a trinomial to the third degree because of this right here, being raised to the third degree. All right, just a quick lesson on our vocabulary, what we got to be paying attention to when we look at this stuff. All right, just a quick run through real quick. Monomial, okay, x to the first degree of 1, right here. Trinomial, y to the second. These two can combine, okay, degree of 2. Right here, binomial, there's 2. Degree to the third, 1, 2, 3. That's what you're looking at right there. And right here is not a polynomial because this one has a negative exponent. That's really on the other side of the fraction line. That's what you're talking about here, and that's what you need to look for. All right, so now we have forms that we put this into, or well, we have a standard form that we actually list out our polynomials is really what it is. All right. And what it is where you take and you put the greatest power to the front, or sorry, not power, greatest degree to the front. Okay, so you add them up and you put the one with the largest degree out front. And then you place them in order according to their degrees. And this is just a standard way of how we set these up. It makes it easier to combine like terms and to work through and see what's going on in our problems. So that's really what we do. All right, the leading coefficient is the number that's in front of the highest degree monomial in there, right? So when they set it up here, this 4, that's the leading coefficient. The x to the 3 is the greatest degree. And if you look, you can see how they kind of set that up. And we're going to use this. You have to be able to do this. This is something that we're going to go through and we're going to work with. All right? Standard form, and we're going to show how to do this here in just a second, okay? And because we're going to do that whenever we actually work some problems. And then what we're going to do is we're actually going to add different polynomials together. So that's what we're about to get to do. We're going to take and we're going to combine different polynomials and go about that right. So adding and subtracting polynomials. As when you look at this, you should look at that and go, oh, hey, that's just all addition all the way through there. Well, if it's all addition, then we don't really need these parentheses, right? Because this is addition, 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 and that's really the addition of a negative number, right? When we come in here and we do this, click, click, we're adding a negative number. That's really all that is. That's what subtraction is, all right? So I don't need all of these parentheses here. I get to get rid of them, right? I don't need them, okay? Once I get rid of those, now I'm looking at it, and that's just combining like terms, all right? So in order for it to be a like term, it has to have the same variables raised to the same powers, all right? Well, if we have that, then all we need to do is take these and rearrange these so that our like terms are together. This is where I was saying putting it in the standard form for polynomials. Well, that's what we're doing. We're going to rearrange. So we have 2c to the second plus, and notice what I just did right there. I crossed that out. It makes it easier to recognize which ones I've already moved and which ones I haven't. So 2c to the second plus 5c to the second. And remember, this goes with this, okay? So 2c second plus 5c second plus 6c plus 4 plus negative 7 plus 4 plus negative 7. Now I'm in order. I'm in standard form for polynomial. Now all I'm doing is actually combining my like terms. Well, 2c to the square plus 5c to the square get you 7c to the second plus 6c. There are no other c's with an exponent of 1, so I'm going to keep going. Plus negative 3. And then I look, can I do anything else with this? No, I do not have any other like terms in there. This is in its simplest form, which is what we want. We want these things in our simplest form, right? Because this is a lot to write, where this gets us to something that's manageable and workable, okay? Same thing here. Look through it. Check to see if there's anything you can do inside those parentheses, then start moving outside of it, right? Negative 8xy plus 3x squared minus 5y plus 4x squared minus 2y plus 6xy. It's all addition. I can get rid of the parentheses. I don't need them. Makes it easy on me. Okay? Now, you want to move your largest degree to the front. That's what you're looking at. Okay? So 3x squared, x to the second. I'm going to take this one to the front. 3x to the second. Even though technically these two are second degree too, I want to move this one here. You'll see this later on coming into our next stuff, that this is the way this is done. But right now, let's keep it simple and move these here, okay? So, have that, plus 4x squared, have that. And remember, these go here, don't lose those. That's the common mistake that you're gonna see, losing those subtraction signs. Be careful with those. So I have those, and then I have plus negative 8xy plus 6xy. There and there, plus negative 5y plus negative 2y. That gets that, that gets that. Now I'm just going to combine my like terms. Okay, x to the second power, can add those together, you get 7x squared plus a negative plus a positive, subtract, keep the sign of the bigger number. Note, make sure that these two are actually exact, because that's one of those things that you'll mess up later on. Okay, so we get negative 2xy plus, and now we're going to combine these two, negative 7y. Okay, so this is one way to write this. The other way to write this, 7x squared minus 2xy minus 7y. Either way, I will accept either one of these because I know they're the same thing and I'm perfectly fine with that. If you're looking at multiple choice answers, it's probably going to be this bottom one. And some teachers will only take it in this form also. Personally, I don't care. I like them both. As long as you're clear that these are negative, I'm good. Either way. All right. So now that was addition. Let's take a look at subtraction here. Well, now we're taking this and subtracting this out of it. All right. But this goes with everything inside of there. So now you got to take this and distribute it to everything inside theirs. Now remember, there's a invisible 1 in front of this. So what you really have is this negative 1 being multiplied all the way through here, right? So what you can do is click, click, and now distribute this here, okay? And a lot of people will just say, oh, well, you just need to change out the signs inside there. Absolutely. That's exactly what you do. You come in here and 2x plus 3x squared plus, and I'm going to change that to negative 7. I'm going to do click, click right there. So plus 8x squared. And now that's something I can work with. Now we rearrange it, and then we start combining our like terms. But a lot of people forget to distribute this negative through. Be careful, that's a common mistake. Be aware of that. All right, now move our degrees to the front, right? The largest degree to the front. So our largest degree is 3x squared plus 8x squared plus, so that's that, 2x here plus -7. Now you're going to combine your like terms. 8, 3, 11x squared plus 2x plus -7, or 11x squared plus 2x minus 7. Your leading coefficient is 11, your highest degree is 2. This is a trinomial, and you're good, and you should be able to identify all that. Okay? Watch that. People mess that up all the time. Okay? Same thing here, but you got to watch what's going on with these numbers. Okay? It's minus there, addition there, subtraction in between the two, so we got to distribute this through. Okay? Addition and subtraction. Okay, so the first thing I'm going to do is I'm going to come in here, I'm going to just change all my signs. I don't like it. Or subtraction to addition, right there. Okay, now I'm going to show you the other way that I teach this. I teach it this way here, and then, all right, I show it here as distributing a -1 through for some students, and then I'm going to show it here for other students. Change all the signs. Okay, whichever one you like better, whichever way works for you, let's do it that way, because as long as you're consistent with it, you're going to be happy with it. Okay, so this changes, goes here, goes here, goes here, and we have 4rxt plus -8r squared x plus x squared plus -6rx squared. Sorry, my eyes are watering, give me just a second. Plus -5rxt plus 2x squared. Notice everything inside of here, all their signs changed. Okay? Make sure I got them right. Okay, all the signs changed in there. Now we're going to line them up according to degree. Well, we have, okay, so we have 3 degree here, we have 3 degree here, we have 3 degree here, we have 3 degree here. Okay, so we're just going to pick one and put it in front, because at a certain point you have to just put the one in front. I'm going to lead, I think, with this -8r squared x. That's that one, okay? Plus, and then I'm going to move this one here, -6rx squared, because I want to show something with this here in just a second. Plus 4rxt plus -5rxt. So that's that one, and this is this one, plus, and this is x squared plus 2x squared. That gets that one, that gets that one. Imagine trying to do that without crossing them out. And keeping it straight on what you've put where. That's a lot of variables all in a row. Be careful with that. Now here's what I want you to notice, and this is why I put these first. It's more for the teaching than anything else. Look at this. -8r squared x, okay, plus -6r to the first power, x to the second power. A lot of students will take these and try and combine them, but those are not like terms. You got to have the same variable raised to the same power. That r is not raised to the same power. Those x's are not raised to the same power. Those are not like terms. Be aware of that. Watch that. But what we do have is 4rxt plus -5rxt. Those are like terms. We can use those. We can combine those. And then we have these two over here. They're like terms also. Okay? So we can combine these. So we're going to rewrite this. negative 8r squared x, and I'm going to go ahead and put this as minus 6rx squared. I just think it looks a little cleaner in this instance. And then we're going to combine these. Well, 4 plus a negative 5, subtract, keep the sign of the bigger number. So minus rxt. Remember, if there's no number there, it's 1. So we have a 1 here. So we have negative 8rx squared, or sorry, r squared x minus 6rx squared minus rxt plus, and then we got to combine these two. Well, in front of that is an imaginary 1, so 1 plus 2 gets us 3x squared. Okay? Now, that's a lot to recognize while you're going through there and not make a mistake. There's a lot of places to make a small mistake in this. Okay? Be aware of it. Pay attention. Cross these things out when you get done with them. There's no reason not to. You know, write them down, cross them out. Make sure you get it correct. Take your time. So many places to make mistakes here. Okay, so be aware. Know what a polynomial is. Know what a monomial is, a trinomial, a binomial. Know what the degree is. Know what the leading coefficient is. Know how to put it into the standard form, leading highest degree forward. Let's see here. Know how to combine your like terms. That's a big thing that we're doing. You got to know that. I think that's it. Okay. If you have any questions, any help, let me know.